Hello, another quick video. This time we're going to be looking at sine rule, which again was set for year 10 at Farnborough last week. First step, really important. We know about labelling up for right angle triangle trigonometry. We've got to make sure we can label up a non-right angle triangle as well. So we do that in pairs A, B and C, where the pair of angle and side are opposite each other. So if that is angle A, that is going to be side A, angle B, side B, C and C. Capital for the angle, lowercase for the side. It doesn't actually matter which one we call A, B and C, as long as they're opposite each other. That's important. You can't have B there and C there, or C there and A there, etc. You've got to have the same letter opposite each other. We then have sine rule. So sine rule allows us to work out missing angles and sides in a non-right angle triangle as long as we have a pair given to us. By that I mean we've got an angle and a side given to us that are opposite each other. So we've got either B and B, A and A, or C and C. If we don't have that pair, then we generally would have to use cosine rule. So the sine rule, there's two different versions. One's just the upside, the inverse of the other. We have A over sine A equals B over sine B, or if you flip it upside down, sine A over A, sine B over B. Depending on whether you're looking for a side or an angle, depends on which version you're looking for. If you're looking for a side, it makes life a lot easier if you've got the side on top. So this version, A over sine A equals B over sine B. If you're looking for an angle, it would help to have the angle on the top, so you have sine A on top, etc. So here's just a basic sine rule question. We've got a non-right angle triangle, we've got a couple of angles in it, and we've got one of the sides given, and we're asked for the other side. Technically you could obviously work out the missing angle there, because angles in a triangle sum to 180 degrees, so add those together, take off from 180 will give you that angle. So I know that I do have a pair because I've got 32 degrees opposite 10 centimeters. Because of that, I can definitely use sine rule to solve this problem. So I am going to write out first of all my sine rule. A over sine A equals B over sine B. So I'm going to call the one I know A, so that's A and that's A. The one I don't know I'm going to call B, so that's B and B. So I'm now just going to fill in some numbers into my formula. So A is 10, sine A, sine of the angle, so that's 32 degrees. And then I don't know this side, so I'm going to leave that as B, but I do know that's sine of 84. Now at this point you've got a couple of different choices. Your first choice, you can work out what 10 divided by sine 32, remember that's fraction, so the line just means divide. So we could do that. So put into your calculator 10 divided by sine 32, so that gives us 18.872 decimal places, and then you go from there. Personally, I like to take the bottom of this fraction to the top of the other side first, because at the moment it's divide by sine 84. To undo that, the inverse of it is going to be multiplied by sine 84. So what we do 10 times by sine 84 divided by sine 32 is equal to B. So now I've just got one whole thing I can put straight into my calculator, and it will work out what the side B is. So we can do that. So we've got fraction button, so the fraction button on the calculator is just here. So we've got 10 multiplied by sine of 84, close your brackets up, divided by the sine of 32, again close brackets, so that gives me B is equal to 18 If you'd done it in 2 steps, so you could have done 10 divided by sine of 32, so that gives you 18.87, and that was equal to b over sine 84. Again, to get rid of the divide, you multiply, so we do 18.87. Remember not to round until you get to the end of the question, so I'm just going to keep it in my calculator like that, multiplied by sine of 84, sine of 84, so times sine 84 by the answer, and obviously you get exactly the same answer there, 18.77 centimetres. Personally though, as I say, I would always just take that to the top of the other side and just get your answer all in one foul swoop. Right. So here is another question. If you want to have a go at this one, please just pause now. Okay, so very similar. I've got my link. So I've got 70 degrees is opposite 5, so I know I can definitely use sine rule. I'm looking for a side, so I'm going to use the version of sine rule with the side on top. So a over sine A equals b over sine B. I'm going to put in the values that I know, so I've got 5 over sine 70 is equal to b over sine of 30. So to get b on its own, it's b divided by sine 30. So I'm going to multiply the opposite side by sine 30. So it's going to be 5 times sine 30 divided by sine 70 is equal to b. So we get our calculator. Fraction button to start with. So we've got 5 multiplied by sine 30, close the brackets, divided by sine of 70, and that gives me a b of 2.66 centimetres. If we're looking for an angle instead of the side, there is one extra step, but it's a very similar thing for when you're looking for an angle when you're doing normal right angle trigonometry. So to start with, we're just going to check, have we got a pair? Yes, we have, because we've got 8 and 50. This time though, I'm looking for angles, so I'm going to start with my sine rule on top. So sine A over A, so it's just exactly the same, it's just the inverse, it's the flipped upside down version. So we've got then sine B over B, put the numbers in that I know, so sine of 50 divided by 8 equals the sine of B divided by 10. So again, I'm going to get rid of this divide by multiplying, so I'm going to multiply everything by 10, so 10 times sine 50 divided by 8 is equal to the sine of B. So I'm going to put all that in my calculator. 10, press the fraction button first, 10 times sine of 50, close the brackets, divide by 8, so that gives me 0.957558, etc, etc. Don't round that, don't change it, just leave that exactly as it is. So I know that that's equal to the sine of the angle. So just like when we do normal right angle trigonometry, that's the sine of the angle. So to turn that back into what the angle is, I need to do the sine minus 1, the inverse sine of that answer. So sine to the minus 1 of 0.957, etc, etc, etc. So to do that, we press shift sine. I'm not going to type the whole thing in because I've already got it saved in my calculator, so I'm just going to press that of answer, and it turns it into an angle of 73.25 degrees. Now you can do it all in one foul swoop. You know at the end you're going to use this sine to the minus 1, so I'm going to press that straight away, sine to the minus 1, and then I'm just going to put this whole fraction in. So 10 times sine 50 divided by 8, close the big bracket up, and again we just get there then in one foul swoop. Right, so one last question to try. So again, if you want to try this one yourself, just pause the video. Okay, so this time there is my pair. I've got 62 degrees and I've got 10, so I can definitely use sine rule. So the difficulty this time though, I'm given 12 here, and that would allow me to work out this one. So that's what I'm going to do first. I'm going to use these bits to work out this angle. So I've got sine A over A equals sine B over B. I'm going to put my numbers in. So I've got sine of 62 degrees divided by 10 equals sine of B divided by 12. So rearrange it. Use sine to the minus 1 because I'm going to do this as one fell swoop because I'm going to get rid of that sign there. Sine to the minus 1 of 12 multiplied by sine 62 over 10. 12 just goes up to the top of the other side. So shift sine, press my fraction button, 12 times sine 62, close that bracket, down to the bottom, 10, close the big bracket. What have I done wrong here? Yeah, that's not, that's supposed to be 52, not 62, can't read my own writing, so actually that needs to be 52 instead. So let's just try that again. So I should always check your work. So we've got sine to the minus 1 of 12 times sine 52 instead over 10. Close the big bracket up. Yeah, this time it does work. So I get an angle of 71.02 degrees. So I now know that's 71.02. I know that's 52 degrees. Therefore, the missing angle here, I'm going to do 180, subtract 52, subtract 71.02. So I can do that on my calculator. 180, take away 52, take away the answer I've just got. So that leaves me with 56.98 degrees. So sometimes you have to work to a different angle first before you get to the angle that you want to. Right, hopefully that was useful. There'll be another video coming on cosine rule next.